Okay, geometry guys, this is 3-4 two-column proofs. Now you got to gear up for this one because this is not a easy concept, and takes some time and it takes some thought, and you've got to really think things through from start to finish. So what is a two-column proof? A two-column proof is going to be something to prove something is true in geometry. So a couple things that you need to be aware of. Reflexive, symmetric, and transitive. All right, here's kind of what reflexive says. Reflexive says you are equal, you are congruent to yourself. So one of the biggest places that the reflexive property shows up is if I've got a triangle or two triangles that share a side. So if I kind of draw another triangle off this triangle over here on the right, I call this one, I don't know, K, I can say, you know what, IH is congruent to HI because it's part of both triangles and it's equal to itself, and the reason behind that is the reflexive property. And all it says is that you're equal to yourself. And the reason that we use that is because we're actually realizing that this side or this something like or this side or some other side is part of both triangles. That's how we say it's part of both triangles. Symmetric property basically says if I flip it around, I'm the same thing. Okay, so one way to think about symmetric property is symmetry is that, you know, if you're equal on both sides, it's just like a mirror reflection of yourself. All right. Ooh. So if I look at symmetry, I think about this. I think about, you know, if I have BD, BD is going to be the same thing as DB. Okay, so if I flip around the whole thing, so if AB is congruent to, now let's go back here a second. So if I say AB is congruent to DE, that is the exact same thing as saying DE is congruent to AB. That is both of those are saying the same thing. All right, that is a symmetric property. All I do is switch it around. The transitive property is probably the hardest property to think about. All right, so let's look at the triangles up here. Let's say A is congruent, A and B is congruent to DE is congruent to GH. All right, let's say that I somehow have proven that AB is congruent to DE. All right, I somehow was given enough information to say that. All right, then let's say that I was somehow given enough information to say, you know what, DE is going to be congruent to GH. All right, DE is going to be congruent to GH. You know, I know that because the problem gave that to me, or I know that because I was given the actual measurements, or I was given something to tell me that DE is going to be perpendicular to GH. So now what the transitive property says is this, is I've got AB congruent to DE, DE is congruent to GH. By the transitive property, I get AB congruent to GH. All right, the transitive property, you start thinking about things in a different way. So I mean, kind of the biggest one that I hear before is like in sports, in college sports and professional sports. So I mean, if you think about this, well, here's kind of the transitive property. It doesn't really work in sports, but it works in math. So let's say like the Vikings beat the Bears, but then the Bears beat the Packers. Well, according to the transitive property, since the Vikings beat the Bears and the Bears beat the Packers, by the transitive property, that means the Vikings beat the Packers. Now, of course, that's not really true. We don't know. Or, you know, they haven't played that game yet. So, but that's kind of how the transitive property works. That's kind of putting it into a context for you. All right, so the triangle congruence theorems, we've talked about this before. We've got side, 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 angle, side. Remember, the angle is included. And we've got side, angle, which is going to be the side included. And you've got angle, side when it's the next consecutive side. We've talked about those before, okay? So that's kind of what's going to come up. All right, so let's take a look at what two-column proofs are going to look like. Oh, one more piece, and this will come up. And kind of here's what this says. CPCTC. You only have to read it a couple times to know what it means, but here's kind of what it's saying. Corresponding parts of congruent triangles are congruent. If you know two triangles are congruent, then all of their corresponding parts are congruent. All right, so let's kind of go back. Let's say I know two triangles are congruent by side, side, side. So I can say, you know what? So I say ABC is congruent to XYZ. I somehow have proven that that is true. You know, I was given this information. Somehow I showed enough information to say triangle ABC is congruent to triangle XYZ. Well, now that I've said that, now this kind of goes back to the corresponding parts piece. If I've got two triangles congruent, all their little pieces are congruent. That means the sides are congruent, which we already proved. But now the angles are congruent. So angle A is congruent to angle X, angle B is congruent to angle Y, angle C is congruent to angle Z. Again, once I've proven two triangles are congruent, I can go back and say all their little pieces are congruent. All right, so let's talk a little bit about what a proof looks like. Okay, this is a nice, easy proof. Very, very simple piece here. Number one, we are given these two pieces of information. All right, and we've got to show that these two triangles are congruent to each other. So, two-column proof. Here's what it looks like. You, easily enough, draw two columns. And then you start with your given information. So, NQ congruent to PQ. Statement 2, NY is congruent to PY. All right, these are your statements. And these are your reasons. All right, so how do I know what I know? Well, how do I know that this statement is true? Well, it was given to me. How do I know that statement 2 is true? Well, it was given to me. So now I'm told NQ, this one is congruent to this one, is PQ, and I'm told NY is congruent to PY. Now, somehow I've got to show that the top triangle is congruent to the bottom triangle. So in my mind, I'm thinking, okay, I got to look for an angle. I've got to look for a side. You know, if I can prove this angle is congruent to this angle, you know, that's side angle side, that might be good. If I can do, you know, well, that's about the only thing I can do for an angle. But maybe I can show that this side is part of both triangles and that side's congruent to itself. Hey, look, that side is part of both triangles. So since that side is part of both triangles, that is where that reflexive property comes into play. So it's part of both triangles. So I can say QY is congruent to QY by the reflexive property. That is that's a property, it's an R, not an I. So once I've proven that, I can say these two triangles are congruent because these two sides are congruent to each other. These two sides are congruent to each other. This side's congruent to itself. So I can say triangle NYQ is congruent to triangle PYQ. Why? Side, 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 postulate. Okay, so let's take a look at this one. All right, we know some things here. All right, we know we're given that RQ is parallel to TS. We're given that RQ is congruent to TS. And we got to show that RQT is congruent to TSR. So we're trying to show that this triangle is congruent to this triangle. It's just flipped over. So start with your given statements. Okay, so I'm given that those two are congruent to each other. I'm also given that these two are parallel to each other. They're already marked. So now I got to start thinking, well, how else can I show some things that might be congruent to each other? Well, here's what I know for sure. I know that RT is part of both triangles. So I know that that's going to be congruent to itself. And that was that statement we just talked about, reflexive. But this time, instead of going RT and RT, I want to go RT and then TR. All right, here's why I did that. I did that for a reason. I did that for the sake of correspondence. All right, QRT is this triangle. QRT is this triangle. But if I go in this order, I need to go STR to make it corresponding. So that's why I'm going to go that way, because I want to go triangle RQT is triangle TSR. If you look at what you're trying to prove, what's in the different locations? Well, R here matches up with T here. So they're talking about this point here and this point here. Then they go to QS, then they go to TR, PR. So that's still reflexive, but from the perspective of correspondence, that's what I want. So that's the reflexive property. So now, what else do I know? Okay, well, I know these two things are parallel. These two lines right here are parallel. Well, if they're parallel, I know some things about parallel lines. Well, maybe I can look at seeing some angles might help me out here. So I know the alternate interior angles are congruent. I know alternate exterior angles are congruent. I know corresponding angles are congruent. And I know consecutive interior angles are supplementary. Here's what's going to probably help me out the most, though. It would be awesome if I could somehow, if I could show this one is congruent to this one. All right, it would be awesome if I could show that. And the fact of the matter is I can, because these two lines are parallel. If I consider this my transversal, these end up being alternate interior angles. All right, now, so, all right, cool. Those are alternate interior angles. I know that they are, congruent. So I can say angle QRT congruent to angle STR because they are alternate interior angles are congruent. So now I know that, so my final piece is going to be the triangles. Angle RQT congruent to angle TSR. And why? Well, side, angle, side. Okay, so let's keep going here. So ATR and STR congruent. AT is congruent to ST. Prove S is congruent to A. Now, take a look. I'm not trying to prove that the angles are congruent. I'm trying to prove this individual angle is congruent to this individual angle. But it would help me so much if the triangles were congruent, because then all I could say is, you know what, if the triangles are congruent, then every part's congruent. So I can just say that. Well, let's see if we can prove the triangles are congruent. So you're given ATR is congruent to STR. So they flat out give you that. So write your given statements. So write your given statements and then mark it on the picture if you haven't done so already. If they haven't done so already. So you're given that ATR is congruent to STR. You are also given that AT is congruent to ST. So those two little pieces are, those two little segments are congruent and those two angles are congruent. Well, I can actually prove this is congruent because take a look. This guy is still part of both triangles. So that's what I'm going to say. I'm going to say RT is congruent to RT by reflexive. The reflexive property is your best friend. You like him a lot when you can use him or her because it will help you tremendously in saying things are congruent for a really, really easy reason. So now I've got the triangles are congruent because I've got side, angle, side, side, angle, side. So I'm going to say triangle RAT, triangle RAT is congruent to triangle RST. And the reason for that is side, angle, side. Last step is going to be proving this. So this is going to be my last statement. And the reason for that is this. Once I've proven that the triangles are congruent, once I've shown that the triangles are congruent, that is where I use CPCTC. I can only use this after I've made that statement and then proven that statement. Okay, that's all I got. I know that was a lot, but you've got to think this through and take this piece by piece, otherwise you will get in trouble. Come talk to me with questions.